Section 3.2, now we're going to solve systems still by substitution, but this time there's not going to be a variable by itself originally so that you can just easily substitute it. Okay, so if you notice here as you look at these examples, and these are the examples we're going to look at today, these two examples here, you'll notice that there's not a variable by itself. Okay, there's not a letter that's by itself on one side of the equal sign. So what we're going to have to do here is we're going to actually have to solve one of the equations for the single variable. Okay, and one of the things in determining, okay, well, how do you determine whether you solve for x or you solve for y? Well, in your case, it's going to be easy because there's always going to be either just a y all by itself or just an x all by itself in the example. So it's going to be easy to figure out, okay, what equation am I going to solve for? And then what variable am I going to solve for? Because it's going to determine. It's not always going to be y every time. Okay, so in this case today, it's going to change just a little bit. Okay, but everything else stepwise is exactly the same. Once you get the y by itself, then you're going to plug it into the other equation. And one of the things that you want to make sure when you plug it into the other equation is make sure when you substitute something into an equation, you always put it in parentheses. Okay. That way it will help you, remind you that you have to multiply and distribute things like that. Okay, so let's look at this first example here. The first example is 3x plus 4y equals 12 and 2x plus y equals 10. Now, as I look at this equation, I can see, okay, you know what? I've got a y right here that I can get by. So there is no letter that's by itself. Okay, but in this equation right here, I can see, you know what, I could get y by itself pretty easily. So if I take 2x plus y equals 10, and you know what, since there's nothing else with the y, I want to get y by itself, I'm going to subtract 2. I want to get everything away from the y in this case. So I'm going to subtract 2x, and I get y equals negative 2x and plus 10. Now, this is the part that I'm going to put in. I'm going to take this, negative 2x plus 10, and I'm going to put it in for y in the other equation. So I'm going to put it in for this y right there. Okay, so again, remind me, when I put it in, I want to put it in parentheses. So I go with that top equation, 3x plus 4, and instead of a y now, I'm going to put in parentheses a negative 2x and a plus 10. Okay, and then that's going to equal 12. Notice that this equation is the exact same equation as the top, except for instead of a y, I have a negative 2x plus 10. I substituted the negative 2x plus 10 in. That's why they call this solving by substitution. Okay, then now I want to solve for x, get x by itself. So I'm going to distribute. I got 3x minus 8x and plus 40. Combine my like terms, that's negative 5x. Then subtract 40, and negative 5x is going to equal negative 28. Okay, now if I divide this out, now in this case, my decimal is not going to be, I'm going to have a decimal. Now, I will tell you today as you're going through your examples, you will not have a decimal number. Okay, so your answers will not be in decimal form. They will be whole numbers. I will do this one just to show you here. In this case, let's see here. Our answer is 5.6. Okay, now what do? I'm going to take this 5.6 now, and I'm going to plug it into the equation that I got y by itself for. So y is going to equal negative 2. Again, if I put something in, put it in parentheses, times 5.6, and then we're going to add 10 to that. Well, if I take 5.6 times 2, that gives me 11.2. And we're going to add 10 to that, and so y is going to equal 21.2. Okay, so my solution to this first problem is 5.6 and 21.2. Now, again, the problems that you're going to see on your examples will not have any decimals, but I also wanted to show you that not every one of these problems is nice and neat, easy. Okay, all right, so let's look at this second one now. On this second example, Okay, on the second example, now I want to figure out, okay, which equation am I going to use to solve? Well, that has a number in front, that has a number in front, that has a number in front. Well, this guy doesn't. So what I'm going to do is I'm going to take x plus 3y equals 5. And since x doesn't have a number in front, I'm going to get x by itself this time. So I'm going to subtract 3y. And when I do that, I get x equals negative 3y and plus 5. Okay, now, since I used the top equation to get x by itself, I'm going to take this and I'm going to put it in the bottom equation for the x. Okay? So this is going to be negative 2, and instead of an x, it's going to be negative 3y plus 5, and then minus 4y equals negative 5. Notice again, this equation is the same as this one, except instead of the x, I substituted that in. Then I'm going to distribute. That's positive 6y. That's negative 10. Okay, 6 minus 4 is 2. If I add 10 to each side, and if I divide by 2, again, if I divide by 2, I'm going to end up with a decimal of 2.5. But now I'm going to take this 2.5, and I'm going to plug it in right there. So x equals negative 3 times 2.5 plus 5. Okay, negative 3 times 2.5 is negative 7.5. And if I add 5 to that, that's going to be negative 2.5. So those are my two numbers that I'm looking for. Negative 2.5 is the first variable, x, and 2.5 is the second variable in y. Okay, again, like I said, reminder, now I got examples that are decimals. I just wanted to show you that it is possible to get decimals, but you will not have problems that will have decimals as answers. So if you do, then there's somewhere that you made a mistake. Okay, you should be able to complete your class kick problems now with solving systems by substitution, again, with no variable by itself.